Potential energy is the stored energy an object possesses due to its position or condition. Let's explore real-life examples to better understand how potential energy is observed in different scenarios. Spring. The potential energy is present in a compressed spring, as it possesses stored energy due to its deformation. Inflated balloon. The potential energy resides in the stretched rubber of an inflated balloon, as it stores energy from the applied force used to stretch it. Rock. The potential energy is contained in a rock sitting at the edge of a cliff, as it possesses stored energy based on its position above the ground. Stretched bow. The potential energy is stored in the stretched string of a bow, as it holds energy due to its displacement from its equilibrium position. Hanging fruit. The potential energy is found in a fruit hanging on a tree branch, as it holds stored energy based on its height relative to the ground. Wrecking ball. The potential energy is stored in a wrecking ball, as it possesses energy due to its elevated position. Snow. The potential energy is present in the snow resting on a snow-capped mountain, as it holds stored energy based on its height and gravitational potential. Roller coaster. The potential energy resides in the wagon of a roller coaster, as it stores energy based on its elevated position on the track. Water. The potential energy is stored in the water of dams and reservoirs, as it holds energy due to its elevated position. Pendulum. The potential energy resides in the pendulum bob, as it possesses stored energy based on its displacement from its equilibrium position. Bullet. The potential energy is contained in a bullet before it is fired from a gun, as it holds stored energy due to its position in the chamber. Elastic band. The potential energy is stored in a stretched elastic band, as it possesses energy due to its deformation from its original shape. Pinball. The potential energy is present in the pinball of a pinball machine, as it holds stored energy based on its displacement from its equilibrium position when launched. TV. The potential energy resides in a TV hanging on the wall, as it stores energy based on its position above the floor. Bungee cord. The potential energy is stored in a stretched bungee cord, as it holds stored energy due to its displacement from its resting length. Lantern. The potential energy is contained in a lantern hanging on a rope, as it possesses stored energy based on its height above the ground. Skateboard. The wheels of a skateboard hold potential energy before skating, as they are elevated and store energy due to their position. So, those were the examples of potential energy. Now let's see the equation and solve some related practice problems. The potential energy equation is commonly expressed as PE is equal to mgh, where PE represents potential energy, m is mass, g is the gravitational acceleration, and h is the height. This equation helps calculate potential energy in a system based on mass, gravitational acceleration, and height. Let's solve some practice problems to better understand the potential energy equation. Find the potential energy of a 2 kilograms backpack ready to descend from the edge of a 3.5-meter cliff. Assume a gravitational acceleration value of g equals 9.8 meter per second square. Write down the provided data, plug in the values into the formula, and calculate the potential energy as needed. We need to determine the potential energy, so PE equals question mark. The mass of the backpack is given as m equals 2 kilograms, and it descends from a 3.5-meter cliff, so we will note the height as h equals 3.5 meter. Also, the value of gravitational acceleration is given as g is equal to 9.8 meter per second square. Insert these values into the equation PE equals mgh. Therefore, the calculation becomes PE equals 2 multiplied by 9.81 multiplied by 3.5, which equals 68.67 joule. Therefore, the potential energy of the 2 kilograms backpack about to descend from the cliff edge is 68.67 joule. Let's take one more practice problem. Calculate the potential energy of a 750-gram toy attached to a string, ready to drop from a height of 1.8 meter. Consider a gravitational acceleration value of g as 9.8 meter per second square. Use the given data, input the values into the formula, and determine the potential energy as requested. We need to calculate the potential energy, so write PE equals question mark. There is a toy with a mass of 750 gram, so write M equals 750 gram, which equals 0.75 kilograms. The height is given as h equals 1.8 meter, and the gravitational acceleration value is given as g equals 9.81 meter per second square. Place the given values into the equation PE equals mgh. So the calculation becomes PE is equal to 0.75 multiplied by 9.81 multiplied by 1.8, which gives the value of PE as 13.24 joule. Therefore, the potential energy of the 750-gram toy, ready to drop from a height of 1.8 meter, is 13.24 joule. So, that concludes our discussion on potential energy. If you found this explanation helpful, give the video a like, share it with your friends, and subscribe to the channel.